Trailing edge. Device in aircraft. What is trailing edge device? A trailing edge device is an aerodynamic control surface located on the trailing edge, rear part, of an aircraft's wing. These devices are used to modify the lift and drag characteristics of the wing, improving performance during different phases of flight such as takeoff, landing, maneuvering. Type of trailing edge devices. 1. Plain flaps. Design and structure. Simplest type, a hinged section of the wing's trailing edge. Materials: aluminum or composite skin with internal ribs spars. Function, operation. How it work. Deflects downward like a door hinge, increasing wing camber, curvature. Aerodynamics. Generates moderate lift but creates turbulent drag at high angles. Control. Mechanically linked to cockpit lever, cables or hydraulics. Location. Applications. Where entire trailing edge. Small aircraft. Used in
Cessna 172.
Piper Cherokee. Limitations. Less efficient at high deflection, angles, stall risk.
Plain flaps. These flaps are connected to a hinge at the trailing edge of the wing. These flaps rotate downwards when extended. There is a limitation to the angle of extension and the amount of lift that this flap can generate. Plain flaps. This is because when the flaps are extended, the air flowing over the trailing edge of the wing loses its energy, which can lead to flow separation. When extended over the wings, there is a limitation to the angle of extension and the amount of lift that this flap can generate. This is because when the flaps are extended, the air flowing over the top surface of the wing loses its energy, which can lead to flow separation over the wings.
Aircraft. Function, operation. How it work. Creates a split under the wing, disrupting airflow to increase drag. Aerodynamics. More drag than plain flaps, but better lift at low speeds. Control. Hydraulic actuators. Common in World War II era planes. Location. Applications. Where inboard trailing edge.
Used in Douglas DC-3.
Limitations. Noisy, high drag, obsolete in modern designs.
Split flaps. These flaps extend downwards from the lower surface of the wing. These flaps produce more lift when compared to plain flaps, but also produce more drag. This is why these flaps are not commonly used.
3. Slotted flaps. Design and structure. Advanced feature. A gap slot between flap and wing when extended. Materials. Lightweight composites with precision seals. Function, operation. How it work. Slot channels high energy air over the flap, delaying airflow separation, stall. Aerodynamics. High lift to drag, ratio ideal for short runways. Control. Fly-by-wire or hydraulic systems. Location. Applications. Where mid to inboard trailing edge. Used in
Boeing 737. Airbus A320.
Advantages. Allows steeper descent angles without stalling.
Slotted flaps. When these flaps are extended, there is a slot created between the wings and the flaps. The high-pressure air from the bottom of the wing flows through the slots and over the flaps. This increases the energy of the air on the top surface of the wing and prevents flow separation. The result is more lift and less drag.
4. Fowler flaps. Design and structure. Most complex. Slides backward on tracks before angling downward. Materials. Titanium tracks, composite panels, modern jets. Function, operation. How it work. 1. Extends rearward to increase wing area. 2. Deflects down to maximize camber. Aerodynamics. Largest lift increase of all types with manageable drag. Control. Multiple hydraulic actuators or electric motors. Location. Applications. Where entire inboard trailing edge, often multi-section. Used in
Boeing 747, Airbus A380.
Tech note. Some jets use double triple slotted Fowler flaps for even more lift.
Fowler flaps. These flaps are just like split flaps, but the Fowler flaps travel backwards initially and then extend downwards. When the flaps extend rearwards, the wing area increases, which will increase the lift. However, there is no significant increase in the drag. This setting is ideal for takeoff. When the flaps move downwards, the camber increases. There is a small increase in lift, but a significant increase in drag. This setting is ideal for landing. Fowler flaps, or a variation of Fowler flaps, are installed on most aircraft. A variation of Fowler flaps. Double-slotted Fowler flap. This is a combination of slotted flaps and the Fowler flaps. The flap moves rearward and then extends downwards. There are 2 slots in these flaps, which allows air to flow from the bottom of the wing to the top surface of the flaps. This gives a significant increase in the lift that is generated and greater angle of extension.